Hello everyone, this is our Unit 3 Formative 1 Day 1 video on slope, which is rate of change. On our first problem, we have 2 points here. We're just going to quickly graph these 2 points on my coordinate plane. So 3, 2. Remember, x is here and y is here. So these are x, y, x, y. We go to the right 3 and we go up 2. We put a dot there. We also have -1, -4. We're just going to go to the left 1, down 4. Put a dot there as well. So let me just make a line between them. So there's a line. What we need to do is we need to find the slope. And to find slope, that is the change of y over change of x. So the change of y over change of x, which means rise over run. So when we think about rise, that means going up or down, because that's y movement. So if I start here at the -1, -4 point, I'm just going to kind of count how far up I go. So I'm just going to do a dashed line, and it's going to count. We go 1, 2, 3, 4, 5, up 6. So let me just write +6 here. Now, the run part, that's our horizontal movement. We go 1, 2, 3, 4. So let me just quickly draw that line there. And we went to the right 4. That's also positive as well. So our rise over run is a fraction that is equal to 6 over 4. Now 6 over 4 can reduce. 2 goes into both 6 and 4, so that leaves us with 3 halves, or 3 over 2. That is what we call the slope, which is the rate of change. On our next example here, let me just get these points plotted here. We have -5 and 3, so I'm just going to count 1, 2, 3, 4, 5, up 3. I'm going to put a point right here, because it's -5 and 3. And then we also have +3, -2. So that's, again, 1, 2, 3, to the right, down 2. Just going to put a point right there. Let me just do our number line here. Or our line to connect them. And now we want to find our slope, the rise over run. Couple ways we can do this. I'm just going to start on the left side. At this point, if I want to get from here to here, I have to go down 1, 2, 3, 4, 5. Let me just draw that in there. And then we also have to go to the right. So we go 1, 2, 3, 4, 5, 6, 7, 8. Let me just quickly do that here. Let me fix this up here. Okay, that looks better. So again, I said we went down 5. So that's -5, -5. We went to the right 8, which is +8. So my slope, rise over run, that's equal to -5 over 8. Another way you could do this, let me get a different color here. Another way you could do this, you could start over here on the right point here. So if I wanted to, I could go up. I can go up 5. I then could go to the left to reach that point. Going left, that's a negative movement, so that would be -8. So your slope could also equal 5 over -8. They're both equivalent because there's just a negative on one of the numbers. So in this example, our rate of change, or our slope, is -5/8. Here we have 4 graphs that I want to talk about. The first one, if we recall on our first example, kind of had a positive slope to it. So that's like our first example here. It's a positive slope because it's going from the bottom left up to the right. So that's positive slope. And we're going to say, that's uphill. And it's going left to right. So left to right. Our next example here, which was like problem 2. Our line was going from left to right, downward. So it's going here, downward. We say that's negative slope. So that would be also kind of like going downhill. It's like down a slope. So it's downhill going from left to right. The other 2 problems down here are special types of lines that we encounter. And the first type we have here is a horizontal line. This is a tool. So, and that's just to show mathematically, if we think about the rise over run, on that line, it's not going up or down. So that's 0. But we're running. We can run forever and ever horizontally. It doesn't really matter what that number is. You can go 1, 2, 3, 4. So 1, 2, 3, 4. You could put 4. So that equals 0. The last type is this vertical line here. It's vertical because it goes up and down with no left to right movement to it. Vertical lines always have a slope of undefined. So it's undefined. And mathematically, to see how it's undefined, you got to think of it, okay, so we're rising. I could decide to go up 4 and then there, so that's up 4, but I'm not going left to right, so that's over 0. 4 divided by 0, you can't do it, it's undefined. So vertical lines always have a slope of undefined. This graph here is a time distance graph where it's just showing how over time the distance is increasing. So which one's faster? We want to kind of look at it and think about the steepness of the 2 lines here. So if you look at our graphs, the train is the faster line. Okay, so why is the train graph the faster one? Why is that faster? Well, because the line is steeper. Line is steeper. And what makes it steeper? Steeper is when the slope is big. So you see it's just going up a lot quicker than this one. Okay, so this is the steeper line. So the slower one obviously is the car, because it is not as steep. Okay, not as steep. It's flatter if you want to think of it that way. So again, the steeper the line, the bigger the slope. The flatter, less shallow or shallower line, that is less slope. All right, there's your day one video. Make sure you take all the good notes, and we'll see you on the next day.